Hello, everyone, and welcome to the Future of Look Development, Empowering Artists with Open PBR webinar. My name is Elisa Carpio, Tech Evangelist at Autodesk, and I'm really looking forward to learning from our panel of technologists. Let's go ahead and get started with introductions. Panelists, hello. Please take a moment. Please take a moment to introduce yourself, your role, your organization, and your location. And then there's this fun fact question. What's the latest book or movie or podcast that you've read, seen, or heard? And we're going to do this alphabetically. So we're going to start with Anthony, then Fred, then Jonathan.
Okay, so thank you very much. Hi, everyone. Happy to participate to this conversation on Open PBR with you. My name is Anthony Salvi. I'm Director of Product Management 3D at Adobe, and I'm located in France. Welcome from France. I work on 3D rendering solutions at Adobe, used by Substance 3D products, and as well by Adobe Illustrator and Adobe After Effects. Previously, at Allegorithmic, I explored material capture, new lighting techniques, and contributed to the launch of a new application called Substance 3D Sampler. And in regards of your questions about book and fun fact, I have to admit that I love food. So the last book I read was a cookbook, a vegetarian cookbook. So yeah, that was the little trick. So this is a book for cooking everyday meals for family with children. That's important. And since I have my two daughters at home, cooking sometimes becomes a real challenge, as you can expect sometimes. So that's why reading cookbook helped me.
Thanks, Anthony. We'll go to Fred.
Hello. So my name is Fred. I'm based in London. I work at Autodesk. I've been at Autodesk for 8 years now. I come from the Solid Angle acquisition. So I worked in the Arnold team before, but now I'm looking after other teams at Autodesk as well, namely Bifrost, LookDevX, OpenColorIO, and recently Flame. I'm here to represent the work that we've done with the Arnold team, in particular for Open PBR. In terms of what I've seen recently, I was really impressed, and I enjoyed very much Blue Eye Samurai on Netflix. Great animation series. It was really that's beautiful, a really exciting story and very, very peculiar. I like the setting also in medieval Japan. That's great. That's it.
Thanks, Fred. Jonathan.
Hello, everyone. Yeah, I'm Jonathan Stone. I work at the Lucasfilm Advanced Development Group in San Francisco, California, where I'm a lead rendering engineer. I'm also the lead developer of the MaterialX project under the Academy Software Foundation, and I do a lot of work with the Academy Software Foundation. I've been working at Lucasfilm now for over a decade. A lot of my focus has been real-time rendering tech that I've contributed to many movies and TV shows, Pacific Rim, The Force Awakens, The Mandalorian, the new Lord of the Rings series. And yeah, it's been a lot of fun working there. Let's see, in terms of things that I've seen recently, I really liked Gareth Edwards' new movie, The Creator. It's some very thoughtful science fiction with beautiful world building. And ILM did contribute to that show, but I didn't personally work on it, so I can give it props. Yeah, I think it's really beautiful and worth seeing.
Wow, thank you all for sharing that. We have a vegetarian cookbook to show on to an animated show to a movie. Thank you all for sharing. It's always so cool to get those ideas on books, movies, and podcasts. And so let's go ahead and jump right in. On October 23rd, Open PBR was launched to the world. Open PBR stands for Open Physically Based Rendering, and it is an open standard shading model hosted by the Academy Software Foundation. It was initially created by Autodesk and Adobe with guidance from the MaterialX Technical Steering Committee. My first question is going to be at the highest level. Let's set context, and we're going to start with Jonathan. Jonathan, please share. what is an open standard and how is it related to open source? And I would love it if you could share some examples as well.
Yeah, that's a great question. So these are two very closely interlinked concepts, and they go back to the very beginning of computing. They're not recent inventions. So an open standard, it's essentially just a body of text that's created to describe the ideal behavior of some system. And I guess a classic example would be the C programming language, or HTML, where there isn't one implementation that everyone agrees to use, but there's a standard that defines how it ought to behave in the ideal, and then you bring your own implementation to that. And it can evolve over time with everyone freely able to use it and contribute to it in theory. An open source code base takes that an additional step further, where there's actually an implementation. You can just take it off the shelf, integrate it into your application, and use it, or run a standalone application that might ship with the open source code base. So it is a lot more powerful in that people can just use it without having to bring their own implementation. In practice, often these two ideas, open standards and open source code bases, go hand in hand. And lots of the most famous projects, and this is especially true in media and entertainment, are both open standards and open source code bases. MaterialX being the example that's the closest to me, where it has a normative standard that specifies its ideal behavior, but also a code base that you can just take off the shelf and start using.
Thank you so much, Jonathan. Fred or Anthony, did you want to add anything to that? Very comprehensive, Jonathan, so thank you.
Well, I'd like to say that Open PBR is both a standard and has some open source component to it. Because yeah, you can use Open PBR just with the specification, which is a text in English and maths to describe the behavior of the shader. But also we have an implementation in terms of MaterialX or for the shader. Okay, so we have both, and ideally you should be having both.
Thank you.
Maybe I can add some perspective on products, because what is very, very interesting with the open standards is basically when you develop something, especially if there is a lot of risk or unknown, it's good to rely on something where you can have visibility in time, and as well some guarantee of stability due to the way it has been created in with governance and so on. So that's why open standards helps. They help a lot the industry to move already, because if any company, they have to develop everything, and in the long run for everybody, it doesn't scale. And as we live into an ecosystem anyway, because everybody is using a set of tools, not just one, having a place where we can move step by step with some stability and I would say open governance helps to the adoption of new technologies, because investment they are so big at some point. You need a bit of guarantee on where you bet. So that's why I do think that open standards really helps the industry to going step by step in the new technologies adoption. And as well, I would like to say something important, as open standards and open source community is a back and forth mechanism. There is the adoption mechanism, so very happy to adopt techniques, technologies coming from open standards and open source code, but as well to participate. That's both ways. It's very important because we need some key players or people to participate to get something new, and at the other side of the scope, we need adoptions, because if we do something that nobody else uses, there is no point. So again, I see a very healthy mechanism in place where we participate and as well we adopt, having like that step-by-step increase of adoption of technologies, especially in the 3D world. So that's a very good thing coming from those initiatives.
I really appreciate how all of you, talk about what it is and a bit of the how, but also its impact in the community or in the industry. So thank you all for sharing that. Now, as we talk about open standards, I want to focus a little bit on the role of organizations like the Academy Software Foundation or ASWF. It just rolls a little easier to say that, in working with its members to declare open standards. I too am part of ASWF. I'm definitely on the, I'm not necessarily on the standards kind of work, but I am a member of the diversity and inclusion working group. And so this is really fascinating for me to learn. So Jonathan and panelists, I'd like to ask you to share, what is ASWF, the community, and its role in open standards?
Yeah, so the ASWF, it was really formed out of an observation that open source was becoming increasingly important at the time it was focused on the motion picture industry, but you can really apply it to all of media and entertainment. So around 2018, people got together and talked about how to support the open source projects that were becoming so important to motion picture industry, and to make sure that they had a long future, that they were able to evolve with the times. And people saw the Linux Foundation as a great model for how to make things better, where the Linux Foundation has this very stable structure that supports open source projects with very clear ways for people to participate, clear continuous integration processes to make sure that code changes are working across all the platforms that they need to work on, and very strong community outreach. So the Academy ended up partnering with the Linux Foundation to build the Academy Software Foundation as something focused on effectively media and entertainment. And I think at this point, it's worth noting that the Academy Software Foundation goes beyond just motion pictures, but really to all of media and computer graphics. And we have members of our TSCs on the various projects that come from games, come from 3D web, from all sorts of different domains, where the same types of initiatives that are valuable in, let's say, visual effects and in feature animation are also valuable in their domain. And being able to interchange content between all of those different ecosystems is increasingly valuable.
Fred and Anthony, did you want to add to anything that Jonathan shared about ASWF?
Not necessarily on the ASWF, but I just want to highlight that Autodesk has been really committed to embracing open standards and contributes actually a lot back. So MaterialX, Autodesk is one of the main contributors in MaterialX, like is an important contributor, but I should say that, or other projects like OpenColorIO, or and of course USD, which is not a standard yet. It's becoming one, but is certainly a very important open source, central open source project for our industry.
Yeah. We need this type of let's say organization to really secure, as you mentioned, Jonathan, those technologies to the industry, because as we rely more and more on those, stability is something important. So thanks a lot for making that a reality, and happy to participate as well to that initiative with the Open PBR project and the adoptions of many projects you have in-house.
Gosh.
Sorry, I was just going to add to what Fred and Anthony were saying. Just building upon that, it's worth noting that even before MaterialX was part of the Academy Software Foundation, both Autodesk and Adobe were heavily involved in its design, and they were just working directly with Lucasfilm at the time, and there were some big contributions from both of those teams. Now that it's part of the Academy Software Foundation, I feel it's really opened up the possibility for many, many more teams to join in. And just in the past year, Apple and NVIDIA and other groups have made big contributions as well. So definitely we're seeing the benefits of the Academy Software Foundation's structure and focus on community building. But these are two teams, Adobe and Autodesk, that were working with us long ago, even before the Academy Software Foundation existed.
Okay, I don't know if y'all know this, but one of my love languages is community. So the fact that you said community building, Jonathan, goes straight to my heart because all of us can scale and be better if we do it all together in a way and if we learn from one another. So thank you. And thanks, panelists, for helping us understand a bit more about ASWF and its role. Now let's shift things a bit and focus on Open PBR. And I'm going to start with Fred and Anthony on this one, but again, y'all can riff on this. But thinking back to the beginning part of this journey, right? Could you share how Open PBR work started? And also, if you wouldn't mind, share the problems that both companies were trying to solve.
Yeah, I can answer that. So I think both companies were trying to improve their own material models. The Arnold team and Autodesk released a standard for standard surface a while ago, and Adobe had a similar material model that's called the standard material, the Adobe standard material. And what happened was that actually Adobe reached out to us because they were revising the material model. And Guido Quaroni, who should have been here, but he's not here. He was in the beginning. Like, he reached out and said, "Well, it sounds a bit silly because those two material models are very similar. We have the same customers, and our customers are using both software and exchanging materials between Substance and Arnold. And so is there a possibility to converge?" And we really looked at this from the viewpoint of both our companies. It was not about being open, an open standard or anything. We're just trying to make our own material models evolve. We had lots of things like on the Arnold side, we had lots of backlog and requests for enhancements to standard surface, and it came at the right moment. So we say, yeah, let's give it a try. Had a few meetings. Very quickly, we realized that most of the differences could be we were confident that we could converge to common model, and we worked on the differences between the models and trying to iron any wrinkles. And I have to say that the collaboration was great. There was really good spirits from the beginning. A very quick agreements on, your model is better, or in both direction, and we quickly had a consensus on most of the standard, and then we worked for a long time on improving the remaining points, and we're continuing to do this in Open PBR, but this time in an open fashion. Right, so that was the beginning. It was very exciting. It was very exciting. The engineers were delighted to be able to exchange with their peers. It was very relaxed setting, and yeah, and I think something came out of it that is interesting.
Yeah, maybe thank you, Frederick, because that's very well described. Maybe something to add to that is something very, very, very important. I do think it's really at the core of that project is we are thinking first to our customers, to the artists. And that's why it was then so easy to work together, even though we are not in the same company, because what matters the most for us is how artists can express what they have in mind, how the industry then can share, in a more, easy way, 3D assets, because now today we know that pipelines are, bigger and bigger, and the complexity increase, and there is no point to do anything to not help artists in that field. So I do think that as everybody involved in that project was really focused on the value we can deliver to artists. It was just the best starting point to open any project. And I can really just, say like you, Frederick, it was and it is a real pleasure to work together on that.
As both companies, you all were describing the working, and I just love the natural partnership here. As you all were working to address the challenge, at what point did you decide to reach out to ASWF's MaterialX steering committee? Jonathan, I'd also love to hear from you as well, because I believe you're part of the ASWF's TAC, the Technical Advisor Council.
So yeah, well, before handing it over to you, Jonathan. So just when we were historically, at some point we became certain that we could converge, and we thought we thought it would be a good idea to open it more and making sure the message of the openness of the standard was heard, and very loudly. And what better way to do it? The best way is to put it under the governance of the Academy Software Foundation. We considered other bodies, but we think it's the closest to our objectives and core industries, and it fitted very well the kind of governance we're looking after. And so this is where we reached out to Jonathan to turn this spec into something that is more open.
Yeah, and maybe just to add to that, something important to notice is MaterialX is open already, as well. So as we worked on an open definition of that new material model, what fits best than just shading language open as well to describe then that in code, because as it was mentioned by Frederick, that Open PBR standard material is just a bunch of text. It's text, and some math inside, but just is a way to describe what it is. Then you need code at some point to do something in a tangible way in your product. And feeling, that spirit was very important since the beginning. So that's why as well MaterialX was a perfect candidate to continue that idea of, yes, if we propose something open and for large adoption, MaterialX is already in that field. So then if we need somewhere a way to translate it into code available to a wide range of customers, that's a good idea as well. And I pass the mic to Jonathan on that.
Yeah, thanks, Frederick and Anthony. Yeah, obviously from the Academy Software Foundation side, we were very excited to have the opportunity to turn this into Open PBR into a full open project in the same spirit as MaterialX and OpenColorIO and the rest. It seems like such a natural step forward to have a shading model that there are many voices helping to contribute to how it moves forward, and it can then evolve with the computer graphics field and the industry in a way that can be robustly versioned and can move forward in a structured way. In terms of the association with MaterialX, that also seemed very natural to us for all the reasons that Frederick and Anthony have mentioned, where it provides that code base where you can have the implementation of Open PBR be explicit and people can just download it and use it. And we already have this release structure for MaterialX where if a new version of Open PBR ships with the code base, it can immediately be used and is accessible to artists in tools like Arnold and Karma and Omniverse. I think also there was I think we all perceived there being a great value in being able to leverage some of the existing governance structures, contributor license agreements, CI processes that MaterialX already has up and running. And OpenPBR essentially can inherit those where they're useful and benefit from them. We have made sure that OpenPBR has its own distinct technical steering committee so that it can make decisions independently, but there's a huge overlap between both the user base and the governance structures for MaterialX and OpenPBR, and that's very much by design. Of course, I'm on both of those steering committees, and just recently, Andrea Machazo from Adobe joined the MaterialX technical steering committee, and we see a great benefit in having alignment between the two projects, but where they can also push each other, where innovations that happen, let's say in OpenPBR, can feed back into improvements to the MaterialX project, where it can express things that it couldn't express before based on the needs of OpenPBR. So yeah, we're really happy about this collaboration.
I was going to actually direct this next question to you, Jonathan, but I think I'm going to direct it to all of you, the panelists. I know you've been talking about, how it all started, the problems and challenges you all were trying to focus on. This is I just really want to summarize for the audience. What are your thoughts as to the benefits that OpenPBR brings to creatives? And anyone can start, but this is for all of you.
Many.
Okay.
Please start, Frederick.
All right. Well, first of all, like very selfishly, it's a better standard surface for us. It's an evolution. It's a natural evolution of the standard shader we had before. So even if this whole thing didn't happen, we would go forward on the OpenPBR, on implementing it, because we think it's beneficial to the artists. So just intrinsically, I think it's better. But like having so there's many benefits to having something like this defined in the spec. So first of all, obviously you can exchange between applications, and you can exchange assets between studios or between users. So that's an immediate benefit, right? The other interesting thing is about for an artist, if they're used to using OpenPBR in one software, we can jump in another one and know how things are working. You don't have to relearn how the layering works, which parameters do what, as they were doing with standard surface. But that's just an evolution of that. In fact, we were seeing that a lot of people were defaulting to standard surface for archiving, exchanging assets, because they knew it was supported, widely used. So we want to extend this this spirit to other applications, to all the industry, and make it really truly open. So yeah, in terms of goals and what we wanted to achieve with OpenPBR, that's how I see it.
Maybe something I can add to that is as well that, because one of the biggest challenge was to find the right balance between how that definition, that material is by default, by nature, physically based. So what you get out of the box works as expected in the real world, but as well having enough artistic control to maybe go beyond, or to express some material behaviors that are not maybe possible in the real world. And as well, that's something very very important, because it's easy to jump in and use straightforward what is available out of the box and be secured in a way that everything just works. But as well, if you would like to go beyond, it's possible as well. And I see that that's been a huge benefit, because when you start to go beyond the physically, based material, sometimes you can lost yourself in something, at some point, not working at all, especially in production. So again, one of the biggest, interests is that as well. Be, secured in a physically world by default, by nature, but as well having artistic control. I think that's great.
Just to add to that, I will note that we're also very interested in Open PBR just within Lucasfilm and ILM. We were very excited about Standard Surface and Adobe Standard Material as they've been defined in the past. But the idea of an open shading standard, it provides opportunities internally for our own artists, and also it provides opportunities for exchange between studios when they need to send assets with complete look development back and forth. And Standard Surface has been useful in this capacity in the past, but we feel Open PBR will be even more so. It's a more powerful model, and we expect it to have even wider adoption because of its openness and because of the deep contributions from people outside of one company or two companies over time.
It's so cool to learn about this, but please go ahead.
You raised a good point, because again, if we're gonna provide stability as well for that model with a shared governance, and that will be as well key for adoption, because I know that in the industry many people are waiting on something stable enough, good enough, with good values to rely on, because obviously in the 3D space there is so many issues to fix, to solve, so many space to explore. If on some of them we can be all agree on a shared, a common solution, at least then we can move on to the next step. So I do think that Open PBR offers that as well.
If I can add to that, like for the Arnold team, this is not just a science project. This is something that we are shipping in the current Arnold beta. So you can, if you're part of the beta program, you can try it. The spec is not finalized, so that's why we released the first version of Open PBR. We need to finesse some of the spec and work on the implementation in MaterialX and some other stuff. But as it's defined now, we have a working prototype in beta that you can try, and we want to move to this. We want to eventually make Open PBR the default instead of standard surface for Arnold and Autodesk products. This I saw a question in the chat about that, so I'm trying to address this also. So standard surface is not going to be removed overnight. Don't worry. We're working on being able to convert your scenes to Open PBR, all right, shader by shader, or the whole scene. And at some point, I can't say when, hopefully soon, we'll switch the default to Open PBR and still keeping standard surface for I think many years, but just make it the default, so that the creation of new assets is going to be, will be done on Open PBR, eventually. So the transition will take some time. Don't worry, we'll support a standard surface for a long time. But yeah, we really want this to be the default. We're going to focus on improving this shader and not standard surface.
Just building upon what Frederick just said, I think that's really critical, this idea of conversion and upgrade from previous shading models to Open PBR. And it's worth noting, I'll keep it high level, but there is technology within the MaterialX code base that makes this much more straightforward than it would otherwise be. So because Open PBR can be defined as a MaterialX graph, you can define what are called shader translation graphs between that model and others. So you can take assets back and forth and have consistent quality guarantees for the degree of losslessness or lossiness. I think that's something that we'll start building upon once OpenPBR becomes a 1.0 production version, but it's something that we think is an important part of the value proposition of these two projects collaborating in this way.
Folks, I'm actually going to skip my last question before the questions from our audience because we've got over 10 questions. We've got 11 questions. Are you all good with that? If we just go straight to the audience questions now, here's how it's going to work. It's going to feel like a little bit of a pop quiz or popcorn, but I'm just going to, you know, state the question and then any of the panelists could answer. Are you all ready? The first question is, Open PBR is a great initiative and kudos to Adobe, Autodesk, and ASWF for bringing this to fruition. What kinds of materials does Open PBR not plan to support?
That's a cool question. So if you if you have a keen eye, you'll notice that the spec is not Open PBR, it's Open PBR Surface. Right. So Open PBR is an umbrella project that aims eventually to produce several production shaders. The first one and most important one is a surface shader. Okay, so let's focus on this one. It's really the most important one. But of course, we'd love to standardize on production shaders for hair, for volumes, you know, all the important shaders that you need in production to exchange, you know, ready to render assets. So to answer really the question, it's Open PBR Surface is not is just focusing on the surfaces for now as an Uber shader. But that's already a lot of materials that you can represent.
Absolutely. Yeah, I'll just add to that that I think non-photorealistic rendering is out of scope for the Open PBR project. That's an important part of what artists do in other contexts, but we're really focused on the physically based rendering as, you know, is described in the name itself. There will be support for those non-physically based rendering techniques in other projects like MaterialX and USD, but we're trying to stay focused in this project really on the physically based rendering case.
Okay, I'm just going to keep going, y'all, because there's a lot of questions. The next question, open source implementation in areas like Open PBR and Universal Scene Description, USD, have the potential to be crucial in the film archival process. Are there any initiatives that are tied to archiving negatives of CGI assets through Open PBR?
I can talk a little bit about sort of the digital backlot work that we've thought about, at least on the ASWF and Lucasfilm side. I'm sure others will have thoughts on this as well. The notion of being able to maintain digital backlots that are visually consistent over time, this has been a huge part of what motivated MaterialX and many of the other projects in the Academy Software Foundation initially. And I do see Open PBR as being a very important piece of that puzzle, where the persistence of these assets over time is a huge part of what we are expecting to provide. The idea that an asset that looks a certain way in 2023 can be expected to load into applications of the future and look visually consistent. That's an important piece of what these technologies offer. And it's something that, of course, we at Lucasfilm and ILM consider extremely important. The idea that you can create a droid, you know, for a film, bring it back and expect consistent look, even if the applications that were used to create it are no longer identical to the way that they were when you first did that, or the renderer that you used has evolved. So that's something that's really important to us.
Okay, my next question. I know, y'all, I'm just kind of running through these. Next one is wonderful webinar. I was wondering about your future plans to bring this to educational institutions. Do you have plans to bring this to students?
Specifically students, I'm not sure. It's just like we have you know, student and educational programs at our companies, and because OpenPBR is part of, you know, the software, they're going to be available in terms of yes, through the regular software releases. That's
I
how I
would
see
say,
it from the other standpoint, anyway.
everything is available to anyone. So students or not, you can access to the Git repo.
Yeah.
You can read the spec. You can look at the MaterialX implementation. So there is no barrier at all for students or not. And as you mentioned, Frederick, both company, we have softwares available to students, and we all want to provide Open PBR through our products to students as well. So there is absolutely no, you know, difference between students or others regarding Open PBR as, you know, the project, or who can, you know, dig into, or who can, you know, use it at the end.
Since I have a student in my family, I'll just note that some of the projects that are often popular in educational environments are themselves fully open source or free packages. I'll just name Blender and Unity as two popular examples in education. And we fully expect Open PBR to be available in those applications, and it to be something that students would want to use in those contexts.
Yeah, and actually, the Blender developers have contributed like some of the most interesting feedback to OpenPBR. We gave them early access, and they gave lots of great feedback, and others, and you know, other renderers, other application beyond Adobe and Autodesk. So, like the wide availability and the fact that this standard is documented and you can see even the implementation, like, will make this very valuable to anybody learning about you know, CG in general.
The next question is PBR renderers and their material shader network sets typically handle multiple BXDF lobe layers differently from each other. How does OpenPBR plan to handle the difference?
That's an interesting question that is debated in the team, because you have to strike the balance between having something that is very directive, like having a specific implementation for a BXDF that has its benefit, but at the same time, you want to allow someone to experiment with BXDF, you know, innovate with a BXDF that is slightly different. So we're not sure. There's some consensus on some lobes. Some that are easy. For some others, there's still some debate. So if you have any ideas, just please you know, participate to the debate, so that we can find a solution. But yeah, for now it's not always defined. Jonathan, maybe you want to add to some details.
Yeah, this is such a great question, and a deep. This could be an entire webinar on its own.
Yes.
But yeah, I do think this is where the distinction between the open standard, which specifies the ideal behavior, and the open source code base, they both become important. So with Open PBR, we're able to specify the ideal behavior, point to the papers that we consider the ideal implementations of these in the current day, but we give teams the flexibility to implement things in their own way as needed, whether it's for performance reasons, because they don't want to do that to maintain real-time frame rates, or because they have an approach they think is better. And that's completely fine. So what we're specifying is the ground truth, but people are free to approximate that or extend that if they feel that that's valuable in their implementations. But we do intend to provide reference renders, based on this ground truth, so that people can always compare what they've done back to something that is concrete, and they can see, are they diverging from it too far? Are they approximating too much? Or are they achieving with their implementation something that will still look consistent between their application and others in the industry?
You raised a very good point, Jonathan, because as we are talking about a material definition, it doesn't, rely on a specific techniques, path tracing or real time. But as you mentioned very clearly, we need a ground truth somewhere. So the ground truth come from the, let's say, path tracing techniques, the best as possible. And then, obviously, as you mentioned, for real time, there is a openness to find trade-off or better way to compose with that, because obviously constraints won't be the same. But again, it depends to everybody wants to dig into that to propose something for some approaches to simplify things to run in a runtime engine rasterization, because yeah, we need it as well. It's not just for one specific technique. It's agnostic.
Folks, I'm going to actually, I'm looking through some of the questions. There is something here for Fred, if you wouldn't mind just like answering that and typing the answer. It's the one on, are there plans to make Open PBR and MaterialX eventually in all products? If you could just type in the answer for that. But here's the question. I'm going to actually combine, because there seems to be a little bit of confusion. One, and I'm going to combine them. One is, could you explain the difference between MaterialX and Open PBR? Seems to be a little confusing. And then also, what does Open PBR actually describe? So if you all could maybe take it apart a little bit for the audience.
I can answer what is Open PBR in a few sentences. So it describes the layering, okay, and describes the BSDFs for each layers, but also a parameterization. So a list of parameters and what they represent, what are their ranges, what is their intent. So if it boils down to this, you could make a material in many different ways, having different kinds of layering, but this describes a standard way to layer an UBA material with well-known parameters. That's the shortest answer I can give. I hope it answers the question.
I'd be happy to build upon that, just talking a bit about the distinction between Open PBR and MaterialX. So MaterialX, it's really providing a set of components that you can use to construct shading models and indeed full materials in a very flexible way. But these are very small, fine-grained primitives out of which you could build anything. You could build standard surface, you could build Open PBR, you could build the GLTF PBR, or something that is custom to your own studio. The huge value in Open PBR is that it's providing an artist-facing interface that wraps all of that and provides a consistent set of controls that you can expect to have the same names and the same visual behaviors across many different packages. And it wraps all of that complexity that MaterialX offers you and allows you to not have to think about the way that the shading model is constructed, but just think about the way it's presented to the user.
Maybe another way to look at it is Open PBR is the cookbook. So you have a recipe to follow, but then you have to grab the ingredients, to cook yourself the meal. So MaterialX provides all the ingredients you need, and as you mentioned, there's a back and forth mechanism in place, and the Open PBR is just the cookbook. And if you follow properly the recipe with the right ingredients, at the end you get a good meal, basically.
I love that analogy. Thank you. Thank you.
That's brilliant, Anthony. Thanks so much.
I'm gonna have to like copy that and add that to explain as well. Here's the next question. What makes Open PBR different from OSL?
OSL is a language that can be used to that is entirely flexible. You can build anything out of it. You could implement, and actually through MaterialX is kind of makes it easy to output OSL code from a definition in MaterialX with the MaterialX description. But so it comes back to the previous question. It describes a standard way to implement or to to parameterize a surface. Okay, so OSL is really something general purpose. You can build any shader with it, whereas Open PBR is a specific standard implementation of a shader.
Next question. Will Open PBR run seamlessly on GPU and CPU?
So it depends. It depends on what you want to achieve. So in the case of Arnold, Arnold can run on CPU or GPU, and then Open PBR will be equivalent, will have the same result on CPU and GPU. But you might, your renderer could be a real-time renderer that is running on a phone. And maybe you don't have the computing power to run fully fledged, subsurface scattering in on your phone, or it's more important to have something interactive that visually accurate, and so you can make the choice of your implementation there. So there's no guarantee that it's going to look the same, but the intent is preserved. So even if you've designed an asset that is with Open PBR that is visualized at real-time rates in an approximation, you could take the same asset and render it with an offline renderer with all the bells and the whistles. The intent it will stay in the asset, so you will transport the intent rather than a guaranteed visual representation on any platform, GPU, CPU.
I'll just add. Oh, go ahead, Anthony.
No, thank you. On our side, we provide a unified rendering engine, CPU and GPU for path tracing, but as well with rasterization capabilities for running real-time on GPU. So we will take care of that for customers, basically taking the right, and we think the best choice to cut where we can do some simplification between rasterization techniques and path tracing techniques. But in a nutshell, it will work both CPU and GPU. It's not the main constraints, I would say. So everything that will be available.
Those are both great answers. And yeah, of course, we would expect Open PBR to work in the Maya viewport, which is a real-time renderer, or in Substance Designer, which is a real-time renderer. Similarly, we fully expect it to be available in game engines like Unity and Unreal in the future. And as Frederick noted, it's fine to take approximations, and it's expected that lighting models differ in different contexts. Global illumination may be approximated in some contexts, but the ground truth remains consistent, and that's what designers of real-time implementations, whether they use MaterialX or create their own custom implementations, that's what they're striving to get as close as possible to.
Yeah, and as you said, the parameterization as well, the parameters, the way you interact with the material behaviors, the layering will be the same. So That's very important as well. Even though we have different BXDF to describe, things in code, in practice in the rendering engine, for artists, what will be great will be to transfer their knowledge, whatever the rendering solution is, which is very important.
I think we might have time for this other question, but here it is. Are there any plans to support spectral-based workflows? And thanks for the event, but are there any plans to support spectral-based workflows?
Depends on your renderer. There's, I think this, it really depends on your renderer. I'm not sure if there's anything that is like we have to define the color space, and that's defined in the spec, in which we specify the colors that are input in Open PBR. I'm not sure if there's anything that is really you need to change for spectral if your renderer is spectral. Help me, Jonathan. I can't think of anything off the top of my mind. For sure, a lot of those effects have you have to take into account the spectral aspect of it, thin film or other things, and obviously the color space. But yeah, I don't think there's anything specific to spectral rendering.
This is another incredibly deep topic. So yeah, just staying high level. Yeah, I think we would first need support for that spectral rendering in the underlying MaterialX primitives. And then once that exists, it would be possible to do code generation in a spectral renderer that would actually allow Open PBR to behave spectrally. There would likely be subtle things that would change in the approximations that we use, because some approximations that are common in RGB rendering aren't needed in spectral rendering. And I think there would be additional changes, additional functionality that would be needed, additional logic. This is a conversation we've been having over the years with Weta, since they're very famous for developing a high quality spectral renderer that they use in their films. And we're very interested in collaborating with them to bring spectral rendering into MaterialX. And I think that would be a very natural pathway to bring it into Open PBR if that approach moves forward.
Now, with that said, thank you. We are actually at time. And with that, I want to give a round of thanks to our panelists, first of all, and then thank you to our audience for your questions and for joining us. And with that, have a great rest of your week. Thank you all for joining. See you.